You remember the quadratic formula from grade 10? And some people, I think I said this yesterday, some people love the quadratic formula because it always works. You don't have to try to factor, and so if you're not great at factoring, then you can just default to the quadratic formula, but that's not really the best choice because factoring is way faster, and it's a skill in and of itself. Like, it's something you're supposed to learn how to do, and it is usually something that you can get better at with practice. That's a nice thing about factoring, is some people, it takes a bit longer for them to get good at it, but you still can if you just make sure you do some practice. But anyway, this says we've already seen that there are some. I don't think we actually have in this course, but you may have, and we, I think, talked about it briefly. But there are quadratic equations that you can't factor. I mean, we saw some that are not factorable as well. And so you can't solve by factoring. But any quadratic equation that's solvable can be solved with the quadratic formula. So it'll handle anything and everything. Like I said, that's why some people like it. Now, I'm going to strongly recommend, and to some extent you're going to have to do this, that you try to factor first. And I'm even going to show you a little tool today on how you'll know if you can factor or not. Because otherwise you might spend a long time trying to factor, and then it turns out it's not factorable. So wouldn't it be nice if we could tell easily if something can be factored, and turns out there's a way to do that. So we're going to talk about that today as well. And I'll show you how when you can factor, it's a lot less work, it's a lot faster, so it's a good thing to do. But here it is. Here's the quadratic formula. It is a formula. It is one that you have to memorize. That's it right there. Okay. It comes from standard form, ax squared plus bx plus c. So the a, the b, and the c over here are the same as the a, the b, and the c over there. In other words, we need the coefficients of those terms. And we take those coefficients and put them into the formula. Just want to make sure you get that copied down. And then, example 1, we're going to solve. And we're going to round to 2 decimal places. Ooh, there's a mistake here. I wonder if that's just an error in printing. Yeah, it's an error in printing. It didn't print properly. Interesting. There should be a C there. Oh my gosh, if you didn't get that, make sure you put that in. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. If you don't have, you're going to need a calculator for this. I would strongly recommend you practice with the calculator you're going to use during a test. This is not on the quiz tomorrow, but it will be on the test later on. And you need to know how to put it into a calculator. We're going to simplify it a little bit. It won't be too hard, but you still need to know. So whatever calculator you're going to use for a test, you want to practice using that one so you know how to do it. So if you need to borrow one, or if you even want to borrow one of the good ones, we can make that happen. But I would get their calculator out and make sure you practice right now and make sure you get the same answer. This is where you get to find out if you're doing it right on your calculator before you go and practice on your own. Are we ready to go? Yeah. There's some right here. Do you want one of these ones? So the first thing we need to make sure is that, just like factoring, that our equation is fully simplified in the correct form, ready to go. And this one is. The second one's not quite, it's almost, but the first one is all simplified, everything's on one side, and it's equal to 0. That's hugely important. If it wasn't equal to 0, it's not ready. Okay, everybody got that? Off to the side, I'm going to write out the values of A, B, and C. So what's A? 2, right? It's the coefficient of the x squared term. What's b? Positive 8, the coefficient of the x term. And c is negative 5, the coefficient, the constant, and the sign counts goes along with it. Then I'm going to write out the quadratic formula. And this is a thing that we usually do as part of a communication thing, but it's also really, really crucial that you do it over the next couple days while we're practicing this so that you memorize it. This is how you will memorize it, by writing it out. It's like back in grade school when you used to do spelling tests and you would write the words out over and over and over again, probably to just kind of train your brain how to spell it. So negative b plus or minus the square root of b squared minus 4ac all over 2a. People miss the minus out front. People miss the plus minus. People sometimes miss the a on the bottom or the b squared on the inside. Like when you have to memorize it, you're going to have to really know it, right? Then I take the values, a, b, and c, that I've already written over here, and I just plug them in. So this is equal to negative b plus minus square root of b squared, which is 8 squared, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a, which is 2. Remember this? So far, so good. I think people like the quadratic formula because you don't really have to think. As long as you know the formula, you just kind of do it. You don't have to really try to think of numbers like factoring or that kind of thing, or even think about what kind of a thing you're looking at. You just plug the numbers in and go. So it's the same every time. So here's what I'm going to do. I'm going to simplify the inside with my calculator. So I'm going to do 8 squared minus, my calculator's way too big. Hello? Minus 4 times 2 times negative 5. 4 times 2 times negative 5. And it gave me, something went wrong. This calculator is not going to be a good one to use. Try it on your calculator, see what you get. I'm going to try it on mine, my good one, and see what I can get. Oh, maybe that is right. I think that was right. Did anybody else get 104? Okay, nice. Okay, good. I think, never mind then. I think 104 is good. 104. And then 2 times 2 is 4. So I've simplified inside the square root sign. And I simplified the bottom. Got rid of all brackets, all of that. Okay? Then I'm going to split it up into 2 parts because there's 2 answers here. Negative 8 plus the square root of 104 over 4. And x equals negative 8 minus the square root of 104 over 4. And then I just punch those into my calculator. These are the kinds of questions where you have to do the whole top first and then divide by the bottom, or put the top in brackets on your calculator. So I'm going to do this. Negative 8 plus the square root of 104 hit equals, I got 2.198, divide by 4. And you should get, and you really want to make sure you get this on your calculator, and if you don't get it, it was rounded to 2 decimal places, 0.55. It was 0.549, so the 4 rounds up to a 5. So make sure you can get that answer on your calculator. Then for the next one, I go negative 8 minus the square root of 104, hit equals. You probably did that, Ben, because that's negative 18. when you do the second one where you're subtracting. And then divide by 4. And for this one, I got negative 4.55. And I'm done. Just like factoring, we often got 2 answers. I got 2 answers here. Any questions? Okay, let's try another one. Two things about this one. It's got decimals, and it's not quite in the right form. So I have to move everything to the same side of the equation, right? So we're going to do that first. Everybody ready to go? So I'm going to take the 2.1x over, minus 2.1x, and I'm going to take the 4 over, minus 4 equals 0. Now we've got options. If I'm using the quadratic formula, I can actually solve it like this, and I'd be just fine. Okay? Decimals, quadratic formula is fine with decimals. But if I wanted to get rid of the decimals, what could I do? If I multiply the whole thing by 10 on both sides, but one side has a 0, so that'll be fine. I get, do it on your calculator if you have to, I get 4x squared minus 21x minus 40. Why 10? Because the most decimal places I had was 1. If I had 2 decimal places, I'd have to multiply by 100. If I had 3 decimal places, I'd have to multiply by 1,000. But notice that I had to multiply everything. So 4 times 10 is 40, right? So that one changed too. You can't just change the decimals. You got to change all of them. This means my A value is 4, my B value is negative 21, and my C value is negative 40. But because I'm going to use a quadratic formula anyway, I could have used those decimals. It wouldn't matter which one of these I used, I'll get the same answer. So it's up to you which one you like best. Next step, write down the formula, see if you can do it from memory. And then plug in your numbers. So this is what it looks like before I plug in the numbers. I'm going to take B, negative 21, negative 21. This next one is A, which is 4. And this is A down here, which is 4. And this is C, which is negative 40. I could see people getting this part right here wrong. What's negative 21? Positive 21. But because the formula says negative B, if you're not careful, that's an easy mistake to make. So that's positive 21 plus or minus. Now I'm going to do the inside part. So it's negative, and again, this is negative 21 all squared. So 21 squared is 441. That's always going to be positive. Like I wouldn't even put that negative into my calculator. It's in brackets. So it's going to be gone no matter what. So 441 minus 4 times negative 40 is 1,081. Did you get that? Anybody get that? Two times 4 is 8. Try this on your calculator as well. Any questions? Everybody good? Yes? Not working. Let me see. I would say almost always if you're not getting the right answer, it's because you don't have brackets on top or you're not hitting equals before you divide. So just watch for that. All right, I want you to give this next one a try. It's already set up for us. So we're just going to plug in the numbers. What do you get under the square root sign? 121. And then all of it over 4. 2 times 2 is 4. Very good. Other people get that? 121? And so then I get x equals 5. Now, hold on. Before we do that, what is the square root of 121? Anybody do that, or did you just do it all together? It's 11. So I can keep going with this plus or minus 11 over 4. If you didn't do that and you split it up, it'd be fine. So that means x equals 5 plus 11 over 4, and x equals 5 minus 11 over 4. And 5 plus 11 over 4 is 16 over 4, which is 4. And this is negative 6 over 4, which is negative 3 over 2, or you might have got negative 1/2. Any questions on that? How many people already finished that, got those two answers? A few people. Good. Here's what I want to point out, though. I said before that I was going to show you a little trick to tell when it's factorable. When you get nice answers like this, it means it was factorable. That's not very useful, though, because we're already done. Well, I wouldn't go back and factor it now. But there's another trick in here that shows us this that we can take advantage of, and it's right here. It's this and this. That was a perfect square. Means when I took the square root, I got a whole number, 11. The other ones were decimals when you took the square root. That means it's factorable. Okay? And so I'm going to go back and factor it. You don't have to because we've done a lot of this, but let's see what would happen if I factored it. It would be like this: 2x squared minus 5x minus 12 equals 0. So I'm going to have 2x and x, and this is going to be 4 and 3, and it's minus 4 plus 3. Therefore, 2x plus 3 is 0. 2x is negative 3, and x is negative 3 over 2. This looks familiar, right? Same two answers, but quite a bit less writing and less work to factor. Okay? Any questions on that? Okay, so this thing is called the discriminant. We're going to talk about it over the next couple of days, but what I want you to know is we're going to do it with this question right here. I would do it with any question that I was solving. I would do the discriminant first, and I'm going to show you how you use it. You go off to the side, and you go like this. The discriminant is this: b squared minus 4ac. What is that? That is just the part that's here. The part on, what is it, frozen or something? Oh, it just disappeared when I turned around. That part there is the discriminant, and that's the part that's going to tell us what this thing is like. Just the part under the square root sign. That's the part that we care about the most at first. So for this one, what is it? It's 3 squared minus 4 times 2, 3 squared minus 4 times 2 times 9, which is 9 minus 4 times 2 is 8 times 9 is 72. 9 minus 72 is negative 63. So before I solved, once I got it in the right form, I would do the discriminant, and that's going to tell me how to solve it. Watch, which I'm going to summarize for you in a minute. So that's not a perfect square, so you can't factor. So you're going to use a quadratic formula. Now there's something else going on with this one, but let's write this out one time first. So negative 3 plus minus the square root of 3 squared minus 4 times 2 times 9 over 2 times 2. So I want you to do square root of negative 63 on your calculator. What happens? You get an error. You can't take the square root of a negative number, right? This is something we've talked about lots in math. So this one's not solvable. No solution. Not even not solvable. There's no solution. Now, I just want to summarize something here for us, okay? If you do the discriminant and you get a negative number, there's no solution. You don't have to go and do all this. But if you've done it off to the side, you've got to make sure it's part of your solution. You got to show me why there's no solution. But you could do this and say, therefore, no solution. Okay? But if you forget to do that and you go here, you're going to get to that part, and then you're going to say no solution because you can't take the square root of a negative. So if, we're going to write this down, I think you should write it down too. If b squared minus 4ac is greater than 0, or positive, greater than or equal to 0 actually, then you can solve it. It's solvable. And if it's a perfect square, then you can factor it. And if b squared minus 4ac is less than 0 or negative, then there's no solution. So this is a little trick that you can use to tell if something is factorable or not. Put your pencil down and listen for a minute. You don't have to show this work. You can just do it on your calculator. And if I get 25, then I factor. And if I get something that's not a perfect square, but it's positive, then I do the quadratic formula. And the nice thing is, I've already done all the work for the quadratic formula because I've got that number already. Okay? Does that make sense? We'll try it one more time, and we'll see it in action again. If you get a negative, you could just write this part out. Then you have to write something out to show me why there's no solution, but you could just write this part out. You could write it out like this, or you could write it out like that. But you don't have to show that work, but you should be doing that work. And you have to understand what it means. Okay, we got one more here to do, and this one requires a bit of extra work because it's not in the right form. So I want you to have a crack at expanding this to see if you can get the right answer. Our first step is to get it in a form that's a trinomial so that we can factor or use a quadratic formula, whatever it is we're going to do. And then we'll figure out what to do from there. once you get it expanded and simplified and everything moved to one side, I want you to just stop and wait for a minute. Before you go on, I want you to have the right answer. Hello. Say again? No, I haven't seen her in a while. Okay, there it is. I did 3 steps. Let me walk you through it since it's already done. 2x times x is 2x squared. 2x times 5 is positive 10x. And then negative x minus 5 on one side. On the other side, 3x squared minus 6x, and then x minus 2. I collected these together to get 9, and I collected these together to get negative 5. And then I moved everything to the right so that this was positive. So this was 3 minus 2, negative 5 minus 9. You could just, if you got the wrong answer, you can just scratch it out and write the right answer under if you want.
I brought it to the other side, and everything is just like the opposite side.
Yeah, which is fine. And this is interesting because quadratic formula, as long as you get your signs in the right place, you could still do it. But almost always, I'll tell you, we like to have the x squared term as a positive. So if you did that, you'd have negative x squared plus 14x minus 3 equals 0. Then I would flip all the signs. Multiply by negative 1, and I would just flip all the signs because we're used to, like if I end up factoring this, I do not want a negative out front there. Does that make sense? So it's fine to do it either way. And that's where like I just planned ahead and I saw if I move the 3 over, it'll be negative. So instead I'll move everything the other direction. Okay, here's where we're going to do b squared minus 4ac. Now again, if you're doing this on your own, you don't have to write this out, but you might. It's not that much to just go b squared minus 4ac equals, and you could just write the number. You don't have to show the substitution or anything like that. I'm going to show it just so that people can follow along, but it would be negative 14 squared minus 4 times 1 times 3. So 14 squared minus 12 is 184. And on my calculator, I'm going to hit square root of 184, and I get a decimal. Okay? Not a perfect square. You don't have to write this all out. I'm just explaining. Not perfect square, but it's positive. So it's solvable, but not factorable. See how this tells us a lot about what to do next. And now I know that I have to use the quadratic formula to solve this one. Have to. If that number 184 was a perfect square, like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on and so on and so on, you can factor. And remember, I've already done half of the hard work of quadratic formula. You still have to show your substitution step. But the work is done. So I got 13.78 and 0.22.